Hello everybody. My name is Tansel Selekler. I am the Federal Program Manager for the Nuclear Science User Facilities Program, and Dr. Simon Pimblad is our Chief Scientist. Simon and I will present you today together NSUF Program Overview, NSUF Workscopes, and the special requirements to apply to our workscopes. I will cover the overview of our program, and Simon will give you the detailed information about this year's NSUF Workscopes, changes made from the last year, restrictions, and the important reminders. But before we start, I would like to remind you all workscopes are still in draft format, and there may be changes between the draft document and final workscopes. So I would like to point out that scopes can be changed or removed based on a variety of factors, including final Office of Nuclear Energy Management review, changes to our program priorities, or availability of our funds. Okay, we can go ahead and start. Next slide, please, Simon. Nuclear Science User Facilities, NSUF in short, was originally established in 2007 by Office of Nuclear Energy. We provide access to the researchers to unique and highly specialized nuclear facilities. We also provide technical expertise and assistance with experiment design, fabrication, transport, irradiation, post-irradiation examination, and disposition at no cost to the users. NSUF program specifically focuses on irradiation effects in nuclear fuel and materials. We competitively award our projects through two separate solicitations. The first one is Consolidated Innovative Nuclear Research, which is this one, CINR 4, and this one is open once a year. We are supporting variety of projects through CINR solicitation, ranging from major irradiation, both neutron and ion, to post-irradiation examination and beamline experiments. Types of projects include neutron irradiation and post-irradiation examination. These type of projects typically are between $500,000 to $4 million, and these projects may last up to 7 years. The other one is synchrotron or neutron beamline or post-irradiation only. These type of projects are typically between $50,000 to $750,000, and they can be up to 3 years. Neutron irradiation only projects can be between $500,000 up to $3.5 million, and they can last up to 3 years. Ion or gamma irradiation only projects are between $20,000 and $100,000, and they are up to 3 years. Ion or gamma irradiation and post-irradiation examination projects are between $50,000 and $250,000, and they can run up to 3 years. We also computational projects. We have also computational projects requiring high-performance computing access. The second competitive solicitation we have is rapid turnaround experiments. It is not part of the CINR 4. RTE solicitations are typically open 3 times per year, depending on availability of funding. We offer researchers the opportunity to perform short-term analyses of a limited scope of work, such as use of an ion beam or request for post-irradiation examination requiring use of instruments such as focused ion beam, transmission electron microscope, or scanning electron microscope. RTE awards are around $50,000, and they should be executed within 9 months. RTE solicitations are open to universities, national laboratories, and industry. All proposals, CNR and RTEs, are reviewed and scored for technical merit, relevancy, and feasibility. Proposals must support the Office of Nuclear Energy's mission, and of course, proposals are awarded depending on availability of funding. Next slide, please. NSUF operates as a consortium. Currently, we have 50 user facilities at 19 partner institutions around the country, and 1 international affiliate, which is Belgium's SCK-CEN facility. Of those 19 partner institutions, 9 of them are universities, 8 of them are national laboratories, Center for Advanced Energy Studies facility at INL, and 1 industry partner, which is Westinghouse. These world-class facilities are available to researchers at no cost, with capabilities ranging from neutron, gamma, and ion irradiation to post-irradiation examination. As I mentioned before, we also provide access to the high-performance computing facilities at the Idaho National Laboratory. Next slide, please. Nuclear Fuels and Materials Library is a collection of specialized material specimens from past and ongoing irradiation test campaigns, real-world components from decommissioned nuclear reactors, and donations from other sources. We maintain the library to ensure the inventory remains relevant to current demand in nuclear research. We currently have more than 6,000 specimens from NSUF projects, commercial reactors, research reactors, and legacy research projects. Most of these specimens are neutron irradiated, and we have a small number of ion irradiated material. Everything in Nuclear Fuels and Materials Library is available to the researchers. Access to the materials is granted through the CINR and RTE solicitations. All materials are web-based searchable through our website, which is nsuf.inl.gov. You can browse the materials and search for pedigree documents such as material or fuel composition, irradiation conditions such as temperature, dose, flux, and fluence, specimen configuration, and related publications. So the specimens included in our library are conventional and advanced steels, experimental alloys, high purity elemental materials, ceramics. We have some actinides and various fuel forms. If you are interested in fuel forms, please contact NSUF directly for this specific request. We are always looking for expanding our library, and we have great interest to add new specimens and materials to offer more possibilities and opportunities to the researchers. Suggestions for new materials to include in the nuclear fuels and materials library are always welcome. If you would like to suggest a sample or a specific material to be added, please contact us. Next slide, please. Okay, so we have two main work scopes this year, NSUF-1 and NSUF-2. NSUF-1 is nuclear energy related R&D supported by nuclear science user facilities capabilities. Under this topic, we are seeking proposals for core and structural materials in nuclear fuel behavior and advanced nuclear fuel development. But please note that this work scope is open only to universities. For this work scope, this year, for the first time, NSUF will provide up to $800,000 R&D funding to the university PI, in addition to the access to the NSUF capabilities. The second work scope is NSUF2, which is for access-only applications. This work scope is open to universities, national laboratories, and industry. We are seeking proposals in the areas of core and structural materials in nuclear fuel behavior and advanced nuclear fuel development, and high-performance computing at Idaho National Laboratory. NSUF2 Workscopes do not provide R&D funding, and they are for access only. Both NSUF-1 and NSUF-2 Workscopes, with the exception of high-performance computing access requests, require NSUF readiness reviews. Simon will give you the detailed information about these workscopes, and he will go over the changes from the last year, and also he will remind you the requirements to apply to the NSUF workscopes. And we will be happy to answer your questions if you have any at the end of our presentation. Thank you for listening, and thank you for your interest in NSUF program. Simon, you can take over now.
Thank you very much, Tanzel, and thank you for a very informative and good description of the NSUF and its proposals. As Tanzel mentioned, today I'd like to highlight a few changes in the requirements for this particular year's FOA, as well as describing what we're actually interested in as far as the actual work scopes. So the first major change is that for our NSUF-1 Workscope, this year it is only open to university applicants. This is a change from last year's FOA, where it was available to university, national lab, and industry. The NSUF-2 Workscope is this year available to university, national laboratory, and industry applicants, whereas previously it was only available to industry applicants. I should at this case point out that NSUF has a lot more detailed requirements than other parts of the CINR. The NSUF process is described in depth in Appendix D of the FOA when it is released, and Appendix E contains a copy of the non-negotiable NSUF user agreement that all awardees for either NSUF-1, NSUF-2, or the IRP we are supporting have to sign and agree to. The NSUF process is a little bit more complex, as I mentioned, than standard applications. The NSUF requires a letter of intent in addition to the pre-application, followed by a preliminary and final statement of work, and then of course the full application. All of these 5 documents are submitted by the lead applicant. The dates for these documents currently, though this may change if the FOA requires it, are the letter of intent would be due the 2nd of September, the preliminary application would be due the 22nd of September, as is the case for all pre-apps. The preliminary statement of work would be the 10th of November, with the full statement of work due the 20th of January, and as is the case for all applications, the full application is due the 9th of February. I need to remind you at this stage, because of the work that is required in terms of costing and utilization of the NSUF capabilities, only requested full applications are considered. The cost estimates for use of NSUF facilities are prepared and submitted by NSUF assigned technical leads, and they are included in the final proposal. It is also important to note that for all NSUF proposals, preliminary development has to be completed prior to the award being made. In other words, prior to submission of the full application. This is to make sure that we don't arrive in a situation where a reactor irradiation is about to begin and the materials are not ready. The NSUF readiness criteria are explicitly described within the FOA, and a comment about readiness is required in both the pre-application and full application. If an applicant does not demonstrate readiness, a proposal will not undergo review and will be rejected. Finally, one important thing to note is that all NSUF work, including that by industry, must be non-proprietary. It is expected that all of the results obtained will be published, and furthermore, that there will be made the pre-principal publications and all data will be made available on the DOE's OSTI website. The first Workscope this year's CINR, is the NSUF-1 Workscope, and this is related to nuclear energy related R&D supported by NSUF capabilities. The objective, as Tanzal highlighted, is to provide access to capabilities of the NSUF for research projects specifically supporting the DOE Office of Nuclear Energy Mission. The NSUF-1 project is supporting this year 4 types of project: neutron irradiation and PIE, post-irradiation examination, synchrotron or neutron beam or PIE studies, ion or gamma irradiation only, and ion or gamma irradiation with PIE. One of the restrictions, or the restrictions that are required for these proposals, are that the scope and the duration of the R&D must be identified. This is because, for instance, for a neutron irradiation with PIE study, the potential length of the project will be set up to 7 years, and R&D funding may not be required over the whole of that 7-year period. It's usual for the R&D funding to be taken over a selected 3 of the 7 years. And I want to emphasize at this stage that a requirement of the FOA is that all applications submitted under this Workscope must, I emphasize, must couple funding with NSUF access. R&D funding alone is not allowed. As Tanzal highlighted, this year the NSUF will be providing 800K of R&D funding for the applicant to support research directly associated with the project, in addition to the up to $4 million that it may provide for access to NSUF capabilities. The specific Workscope for the NSUF-1 projects, which I remind you are only available to university applicants, is addressing core and structural materials and nuclear fuels behavior and advanced nuclear fuel development. This Workscope is focused on fundamental understanding of radiation effects in core and structural materials and the behavior of nuclear fuels in reactor. Also, research into advanced nuclear fuels and improving the performance of current nuclear fuels. We have specific areas of interest, including materials aging and degradation methods, and we are also interested in the physics and chemistry of nuclear fuels and irradiation and thermal effects on microstructure and its evolution. For instance, its effect on thermophysical properties and thermomechanical properties. An in-depth description of the areas of interest will be provided or is provided in the FOA. I would like to highlight at this stage that the NSUF is not interested in receiving proposals addressing work on a number of conventionally or additively manufactured materials in which we have funded significant work in the past. This list includes 304 stainless steel, 316 stainless steel, Inconel 718, uncoated zirconium alloys, silicon carbide, and silicon carbide composites. A complete list of previous NSUF awards made under the FY17 to FY21 CINR funding opportunities can be found on the NEUP website, and one is advised to look at those topics prior to making a submission. The NSUF2 NSUF2 Workscope is available to all applicants, to university, national laboratory, and to industry applicants. This Workscope does not, I emphasize, does not include R&D funding. It only provides access to NSUF capabilities. The goal is to provide those capabilities to a wide variety of users across the nuclear energy systems landscape. In this particular area, the NSUF is looking to fund neutron irradiation and PIE projects, synchrotron, neutron beam line or PIE only projects, ion or gamma irradiation only, ion or gamma irradiation with PIE projects, and in addition, computational projects utilizing the INL high-performance computing system. I emphasize again that in this particular case, R&D support is not provided to the applicant. And it's therefore required that the source and scope and duration of R&D funding, which will be used to support the principal investigator and associated investigators, must be identified in the main proposal. And again, the NSUF does not fund travel, salaries, or other costs of the PIE and associated investigators. There are two components to the NSUF2 Workscopes. The first has an identical mission to the NSUF1 Workscope. It addresses core and structural materials and nuclear fuel behavior and advanced nuclear fuel development. The focus is exactly the same as the NSUF1 Workscope, as are the areas of interest. Once again, I emphasize that we are not interested in receiving proposals for work on a number of conventionally and additively manufactured materials, which are listed on this slide and also in the FOA, and that a complete list of previous NSUF awards are available on the NEUP website. The second workscope within the NSUF2 regime addresses high-performance computing at Idaho National Laboratory. In this, we look to provide scientific computing capabilities to support advanced modeling and simulation, utilizing the brand new Sawtooth capability at INL and the already existing Falcon and Lemhi capabilities. The proposal in this area may address a wide range of research activities, including performance of materials in harsh environments, performance of existing light water and advanced nuclear reactors, and multi-scale and multi-physics analyses of nuclear fuel. Support includes not only access to the HPC system, but assistance from INL computer administrators in both logging in and running the code, basic HPC training, software support, and expertise as requested. Available software includes an assortment of tools from computer-aided engineering, chemistry, code development, etc., as listed on this slide and in the FOA. I need to highlight, however, that access to HP resources through this FOA do not provide licenses to software not currently available. Furthermore, that DOE developed software from the NEAMS program or utilization of this software is highly encouraged. The particular INL HPC capabilities that are available are Sawtooth, as I mentioned, the newest INL supercomputer. This is one of the top 50 computers in the country, top 500 computers, well, it is a top 500 computer and currently ranked 32nd as of November 2019. Lemhi, a much smaller system, ranked still within the top 500 computers in the past, and Falcon, which is a workhorse computer that's been in existence for quite a while. Now, at this stage, I need to emphasize again that upon award of an NSUF-supported project, an NSUF user agreement must be signed before activities can begin on the project. If this user agreement is not signed within 30 days of receipt of the project, this may result in cancellation of an award. The NSUF user agreements are a critical part of commencing the NSUF supported CINR FOA opportunities. Finally, I'd like to point out that if you have any questions, these may be addressed to the Federal Program Manager, Tanzel Salekler, who spoke earlier on, to the technical point of contact, Rory Kennedy, who is an INL employee, and also any information that you may have, you should first look on the NSUF website at the address given, nsuf.inl.gov. I would be more than happy now to address any questions that you have regarding this particular funding opportunity.
Okay, Simon, our first question is for NSUF 1.1 Workscopes. Are there any fuels that are not of interest at the moment? For example, for structural materials, you call out specific materials that will not be considered. Can you comment on fuels, please?
As far as I am aware, most fuel cycle fuels would be considered, though in some cases there is the obvious caveat. So for instance, whilst NE is not currently interested in the thorium fuel cycle, comparison of, say, for instance, thorium-based fuels with uranium-based fuel cycle would be of interest. So it all depends on the particular scenario. At the moment, the main focus of interest in terms of deployment in reactor is uranium-based fuel cycles. However, there are obviously niches where one might want to consider other appropriate fuel cycles.
Does NSUF-1 support travel and salaries?
NSUF-1 will provide up to 800K on support for the university researcher. This money comes from the NSUF and it would be used in the way that a typical university grant provided under the CINR operates. So it would provide salaries for graduate students, for faculty members, for postdocs, for travel and for all associated expenses with regard to the particular project. This money is distinct from the money that is provided for NSUF access to capabilities. In other words, the researcher, the PI, would receive a grant for the up to 800K award, and then they are awarded time or utilization, which would be at the appropriate cost that is necessary for the NSUF access. They do not see that, if you like, in their hands. They do not see that component of the award.
We have Tansel and Rory here in case they would like to add any comments. I have unmuted you on my side. So if you guys have any comments, please go ahead and talk as we go along in the Q&A.
Yeah,
Okay.
just let me add to Simon's comments one thing. When the project is awarded, it goes through a technical review. That means we actually review the travel, the salary, everything in that project. So yes, the travel is allowed, but it will be reviewed.
Okay, next question. Does the non-proprietary requirement apply to both NSUF-1 and NSUF-2?
Yes.
Yes, that's with all CINRs.
Yes.
In particular, that you would expect us in NSUF1 to be non-proprietary because it's a university award. And if you like, the metric that many university professors are judged by when they come to promotion, etc., is publication. The reason that we highlight it for NSUF2 is that it's those are available to industry, and sometimes there are commercial considerations, and so one would not expect to fund a piece of work that is commercially important or is required commercially, and that the particular company is not prepared to make the results available to the general community.
Okay, what are considered as radiation resistant materials?
Well, I presume that the individual is talking about structural materials. I mean, and obviously DOE is very interested in understanding the behavior and the performance of radiation resistant materials. In terms of, we obviously don't want to bias a particular or tell an applicant they have to work on a particular material. There have been a number of suggestions in the literature about materials that are more radiation resistant than others. But as I say, you know, that's up to the applicant to define. And if you like, the hypothesis is why those materials are radiation resistant.
For NSUF 2.2 in high-performance computing, is there an expected limit on the number of core GPU hours per year allowed? And is there any limitation regarding the number of PIs?
As Tansel mentioned earlier on, the proposals are undergo review. And so the concept or the idea there would be that the applicant would be expected to justify the amount of core hours that they are receiving, and then it would be reviewed as whether it was appropriate or not. So that would be part of the review criteria. In terms of the number of PIs, as far as I'm aware, there's been in the past never an explicit limit on the number of PIs. How shall I put it? From my experience writing proposals, the actual issue there is the herding cats issue. How can you write and maintain a coherent project if you have too many individuals pulling in different directions? So to the first question, the number of core hours is reviewed and it needs to be justified in the proposal. To the second question, there is no explicit limit. However, organizationally and in terms of a management plan, that is always something that is difficult if you have too many. So that's for the PI or the PI and co-Is to decide.
Okay, can national lab researchers participate as a collaborator for NSUF 1.1 when university PIs serve as the lead?
Yes, they can. However, there is a maximum of 20% of the money that can go to non-university partners, total 20% for this particular financial year's FOA. These rules were explicitly described in the general introduction earlier on, and they will be explicitly stated within the FOA.
Would modified 304 and 316 steels with purposely added additives be something that could be considered in these work scopes?
I think that the answer to that question is it would depend very much on the hypothesis. I mean, Rory may want to chime in here as he's the director of the NSUF, but my feeling is that the only reason that we would want to consider those particular materials was if somebody was looking at the effects of the additives rather than the performance of the material itself.
If a PI desires a particular researcher to perform work under an NSUF agreement, should the NSUF facility researcher be included as a co-PI, collaborator, or under another title in the proposal?
according to the rules that are stated in this FOA, all NSUF technical leads and technical staff are supposed that are known. So in other words, the technical lead at the very least needs to be included as a collaborator on the proposal. If somebody is included as a co-I, the usual implication is that they will be receiving some of the R&D funding. So for instance, in NSUF1. So that may be a reason why somebody would be included as a collaborator rather than as a co-I. But yes, if somebody wants a specific person to be involved, they should certainly, as a technical lead or as a technical associate, shall we say, they should certainly include them as a co-I on the proposal. So I must say that the NSUF will specify who we believe is the best technical lead. Sorry, I beg your pardon.
Sorry, Simon, I interrupted you. Following up on that question on fuel types, is there any preference on the types of reactors or applications? For example, TRISO fuel, accident tolerant fuels, as compared to more traditional fuel types like UO2 and metallic fuels?
Okay. We specifically state in the FOA that we're interested in both conventional and advanced reactor fuel types. And one of the things that Catherine Huff highlighted was the fact that we're not trying to be overly specific in what we actually request in this particular year's FOA. So in principle, there should be no reasons why any particular fuel type could not be considered. But again, you know, it all comes down to any kind of research proposal. You have to be demonstrating that you're doing something novel and new and of value to DOE NE's mission. So there's not much point repeating work that's already been done and is available either in the literature or on publicly available national laboratory reports.
For NSUF 1.1, would you be interested in projects with modeling in conjunction with the experiments with NSUF facilities?
Not only would we be interested, we would be very encouraging about modeling with and simulation with experimental projects. We regard the combination of experiment and theory and computation as being a positive in terms of the performance of a project. It allows for both understanding at the same time as developing a new knowledge base. So it's highly encouraged.
Okay, could you please repeat the letter of intent and pre-application deadlines?
Okay, these will be specified in the FOA, and those will be the final dates. But currently, we are aiming for the letter of intent on the 2nd of September, the pre-application date, as for all of the CINR FOA, on the 22nd of September, the NSUF preliminary scope of work on the 10th of November, the final SOW on the 20th of January, and the full application, as with all full applications, on the 9th of February. As I said, those are provisional dates at the moment, are subject to change until the final FOA is issued, and they will be stated on the front page, the cover page of the FOA when it is released.
Simon, this is Drew. I just wanted to mention something about the due dates, especially concerning the IRP scope. We understand that the letter of intent date being so soon is hard to create a large IRP team, and the intention of the letter of intent is to outline the NSUF request, not necessarily establish a team and have an entire research scope written in that time frame. So just wanted to clarify that as we're talking about due dates.
Yeah, the IRP is being presented on Wednesday, and there is a specific slide in the pack that I think it's Ken Keller will be presenting, which outlines in detail what we want and when, and with specification of that particular point.
In the gun.
Okay,
And
next
I will be
question.
for any questions about the IRP, because I'm the technical point of contact for that.
Okay, if we use NSUF to prepare samples and then build a separate facility to study the effect of irradiation on the material's other performance, would that be considered as an appropriate topic for NSUF-1?
The focus of the NSUF is on the performance of irradiated materials and nuclear fuels. So any NSUF project has to be based upon either the performance of a fuel type or the performance of an irradiated material. So that is the primary criteria. So it has to be an irradiated material for it to meet an NSUF scope. Does that answer the question?
If the person who asked that has additional questions, please type them in. Our next, oh, hold on, Rory would like to say something. It says I need to unmute him. Hang on.
Can you hear me now?
We can hear you, yes.
Okay, great. I would like to go back and have a comment about the question in reference to the high performance computing access in NSUF1. Yes, and it is encouraged. However, the computational effort in those proposals or in those projects can't be the majority of the work, at the most up to 50%. So there has to be a very significant experimental part to those applications.
Yeah,
Okay, that's all I wanted to add.
Thank you, Rory. Okay, next question. Do all uranium-based fuels need to be considered, such as UZR, UMO, UN, and UC?
Well, I mean, we don't require people to consider all of those fuels. Now, in terms of the fuels that are usually of interest, UMOLY, of course, is not part of DOE NE's mission. That's a different part of DOE. And so what would not normally be considered as a fuel that we are interested in within the CINR FOA. All of the other fuels, though, there's no reason why they could not be the subject of a proposal.
Okay, would you say industry PIs are encouraged for NSUF 1.1 applications?
Sorry, industry is not allowed to apply to NSUF 1.1. It's only available for university applicants. However, industry PIs are certainly encouraged for the NSUF2 Workscopes.
But industry collaborators, they don't, not the PI, but
Yes, so industry collaborators are encouraged, and as I mentioned,
they're more than
before,
welcome to be collaborators on the applications.
and up to 20% of funding can go to sources that are not universities. That's a total of 20%. So if you have a national lab and an industry partner, they can receive between them up to 20% of the R&D funding, a maximum of 20%.
As a follow-up to Rory's comments on NSUF 1.1, can the projects be led by modeling PIs?
Well, we don't make a distinction between a modeling PI and an experimental PI. What we do require is that the majority of the project is of experimental nature. So if you like, the spend, the projected spend, the majority of the spend is of an experimental nature. and so utilizing NSUF access to NSUF capabilities. And if you like, the whole purpose of the R&D funding is to support the NSUF, the work that's done at the NSUF capabilities.
Okay, next question. Can the cost of software licenses be included in the application for high performance computing time, or is a separate application required, one for funding and one for computing time?
We do not provide support for software in the HPC component of NSUF2. What we do merely provide there is access to the computers, so in other words, cycles, and access to capabilities, software that is already available on the computer, subject to export control issues and the like. This is the point that I made about software licenses. So no, that an additional funding source would be necessary for any software that is not currently extant on the NSUF, no, sorry, on the INL HPC capabilities.
Okay, next question. A few specific materials in conventional and additive forms were excluded. How about these materials made by other methods or dissimilar metal welds?
Okay. We are very interested in dissimilar material joining, and in that sense, those materials are appropriate. However, I'm not aware of another way of making bulk coupons, shall we say, those materials, other than additive manufacturing or conventional methods. So yes, we are interested in dissimilar joining of dissimilar materials and the performance of welds, etc., in a radiation environment. No, we are not interested in those specific materials in bulk form, either produced conventionally or by additive manufacturing.
For NSUF 1.1, will unique characterization capabilities complementary to current NSUF capabilities from the university lead be considered adding value to the proposed experiments in the review process?
Obviously, we are interested in obtaining the most possible information from these research projects. So yes, obviously that's part of the proposal and the review process, is to demonstrate that you have a holistic program of research that is going to develop value and impact, as well as good science and engineering.
Okay, what fraction of the award can go to experimental measurements which are independent of the NSUF irradiations, such as TEM or SEM, etc.?
How the money is allocated at the university and the university partners is at the discretion of the PI. However, that has to be described in the full proposal, and therefore will be reviewed for scientific relevance and appropriateness. I mean, obviously, one would expect the NSUF funds essentially all the work that is performed at the NSUF partner capabilities, and so one would expect that the vast majority of the 800K that is spent, that is awarded to the PI, will be spent on supporting staff, students, etc., at the university, and access to university equipment for experimental purposes.
Okay, it looks like this is our last question. It says, you mentioned that NE is not interested in thorium fuel cycles. Are thorium-related projects without a U/PU component specifically discouraged from applying per FOA instructions?
Okay, it does not specify that in the instructions. I said, I think to be precise, that the thorium fuel cycle is not currently a major interest at DOE NE, and I believe that that is the case. obviously one is interested in understanding the behavior of all of the actinides, but in particular, you know, the focus at the moment, given advanced reactors and conventional reactors, is obviously on the uranium fuel cycle. And so any interest in the thorium fuel cycle would not be addressing the DOE NE mission unless it is somehow tied in terms of either developing knowledge, developing information, etc., that is then applicable, or providing understanding, shall we say, to fuel cycles that are currently of interest to DOE in its mission of supporting the conventional LWR fleet, or developing and deploying the current advanced reactors that are being postulated or conceptualized by the industry.
Okay, Simon, I believe that's all the questions we have right now. Thanks, Simon, Tansel, and Rory for being here.